interacted with, all of this stuff shows up. So this is the kind of apps that are very, very simple. And now from now till the session end tomorrow, my hope is that I will help you first set up uh, a basic self-hosted Fluvio cluster. And once you have that set up, I'm going to show you patterns of how to navigate this system, and then patterns of building data flows, stream processing data flows, which you can actually use some SQL queries. You can use some functions which could be written in Rust, and we have clients in Rust and Python and so on, where you can actually build these flows. So I'll just basically now give you a little bit of time to ask any questions that you may have. Then we will go through a setup, basic example, then kind of build on top of that, give you examples of different data flows, and build the complexity so that you've at least seen, at least 2 or 3 different examples of data flows. And I will share with you how the integration layer works of like accessing different data sources and things like that, right? Let me pause and ask if anyone has any questions so far based on what I've described. Does this make sense? Is this clear? Do you have any doubts, any questions? Please raise your hand. I see a thumbs up. That's good. If everything is good, feel free to do that. A bunch of thumbs ups would be good as well. Excellent. Okay. So let's get our feet wet and our hands dirty, shall we? Let's do it this way. So now setup. For the setup, I just wanted to ask one thing, and maybe my chat share will not be there. So I had actually another setup related thing just to capture what kind of system you're using. Forget about this first question. Actually, second question. No, I just want to know. Can you folks type? I just want to know how many of you are actually using Windows, because obviously any of these systems, they work best on Mac and Linux. If you're using Windows, then you may want to use WSL, the Windows subsystem for Linux. Because I mean, obviously PowerShell when we are using command line doesn't work the same way. So I'm gonna I'm just gonna give you that, because if you don't have Windows subsystem for Linux, then you probably want to like use something like Replit or something like that, where you'd find a Nix environment to play around. And I can help you with that. We also have actually Docker set up in here. So all the documentation, if you come here, you can just search works well. So you can you can go to the Docker setup, and that will set up. Now the thing is that when you set up this kind of a thing, this kind of gets into the concept of it. I will share with you the concept. I'll just get you the basic setup and the install going, and then I can share with you the concept. The main thing that is kind of a gotcha if you're using Docker for a system like this, which is highly available, massively parallel, and things like that, is the networking. And as long as you follow this stuff, it will work perfectly fine. And if you have any issues, just let us know on Discord. And all of you who raised your hand for the Windows thing can you can take your hand down unless you have a question. Okay, perfect. So let's just go through this basic installation bit so that we have something set. Now, Fluvio actually is a very tiny binary. So this project is written entirely from the ground up in Rust. As you must have seen in here, we have SDKs, so you can see most of it is in Rust. We have, however, clients here which are in Python and in Node. I would recommend use the Python one. There are a lot of you who are using Python one. The Node one will not have all of the APIs exposed because obviously when you're code generating and building and stuff like that, it maintaining multiple client SDKs is a thing that is challenging. So I would recommend that you use the Python client, and I'll show you how to do that. obviously, if you want to try out Rust, our documentation is fairly healthy state. So feel free to venture in as well, and we are happy to help you with whatever you want to go with. The installation is very simple. Okay, so you just run this script, and I will run it on my terminal. So I'm gonna come here. This is my terminal, and all you do is run this. And what it does is it runs this installation script and downloads what we call Fluvio version manager. And Fluvio version manager actually installs all of these things, which this is the core Fluvio. This is to interface with the cloud, which we would ideally not require, but in close to the end of the hackathon, we can help you deploy it in cloud, and I will give you a glimpse of what is there in the cloud. This is the runner. CDK is connector development kit, so basically generates the entire boilerplate for creating new connectors. We will take a look at an example of that tomorrow. I will share with you a blog. Smart modules is basically on top of connectors. We were running certain format conversions, like you could change from JSON to XML, or you could apply certain filter on the source data. And one such smart module for JSON transformation is used on that GitHub, the star bot that we have, because you don't want the entire payload. We just pluck the stars and the forks on our repository, and we don't take the rest of the payload. So you can do things like intelligently process only the amount of data that you need to process. And that's SMDK, or Smart Module Development Kit, is for that. Now, there's one thing that this script did not install, which we will actually still need, which I will install right now. But once this installer runs, it's pretty obvious. But if it is not, you just have to copy that last line and paste it and run it on your terminal, which will then add the binary path to the shell, and then you have to do a source and basically refresh your shell profile. That's what you need to do, those two things. And then if you did Fluvio -H, that will give you a list of commands. So Fluvio has a very rich command line interface, right? And you can see we were talking about producer, we were talking about consumer, right? So we'll produce, consume, and the main abstraction, or the main container, you could say, where data is stored in the event streaming paradigm is known as topics. Basically, topics is a layman term for an immutable distributed log, where you can store any kind of data. I mean, it doesn't really care whether you store raw binary or JSON or BSON or protobuf or Avro, doesn't matter, right? As long as you can serialize, deserialize, right? So it stores data in the form of topics, and topic is a distributed immutable log. What that means is you can, maybe I can draw a diagram here. Let me see. So let's say I have a topic called Solana transactions. Okay, so in this topic, I want to store this data. Now, because it's distributed, it can be partitioned, right? Into, so then it would become Solana transactions part. Let's call it, just for simplicity, I'll just say part 1, 2, 3, 4, something like that, right? And the data is stored across these partitions with things around offset management and things like that. Now, let me just give you a sense of what is inside of this system, right? How can I store this data? And you know, let me maybe put something on top of it and say this is like my Solana topic. So Solana TXNS topic, right? So these partitions are where this data will be stored, and there are things like offset management, because let's say there are In Solana, I think there's like every 400 milliseconds, some 18,000 transactions or something like that comes out, right? So if this was a topic and this was these parts, it's basically just storing the data across these partitions and balancing it so that when you're going to try and produce and consume, it's going to consume the data wherever it's located for processing, right? So if you double click on this, right, basically this system has two what's the word, two components. Okay, so there is something known as a streaming controller, and this is true across every system. You'll hear the word control plane and data plane. Okay, so there is a streaming controller. This is the control plane, and then there is a stream processing unit. We call it SPU in short, stream processing unit. Now, obviously, one streaming controller can work with multiple stream processing units. So a massively parallel system is basically distributed in multiple levels, right? So you could have multiple stream processing units taking care of multiple partitions of topic, right? And the streaming controller is the control plane that is controlling all of these things. So we can draw arrows from these things over here, right? And when you install the Fluvio binary, right, there's this notion of bin packing. You just that first thing that you install the Fluvio binary, it's like 37 MB. And it packs up all of these components and all of this code in that single binary, right? So to start a Fluvio cluster, once you have run this install and you've gotten the key, right, you have this command. All you have to do, and I hope that I don't have a cluster running, so I'll just do a status. Oh, actually, this is connecting to the cloud. So let me since this kind of showed up, I'll just talk to you a second about this. So what you're seeing here is I just did a Fluvio cluster status to see what's happening on my system, right? And it says that, hey, it's connected to this particular profile. Now, I know this profile because I recently created this demo, and I can share this YouTube video with you where I'm playing a game, and while I'm playing the game, the movements are basically being mapped out. So you can see it will kind of give you a hint because it's called Unreal Engine Analytics. So we're actually about to publish a plugin which you can plug into any Unreal Engine based game, and you can do live event analytics on that. Now, this is actually on InfinyOn Cloud. So it says this is with profile, right? And this was actually in Fluvio command line. So I have to say Fluvio profile list, and you see that there are a few profiles here. So this is a cloud profile. You can see InfinyOn Cloud. Don't bother with that. I'm going to switch. In your case, it will not be there, right? You will start with a local profile. So I'm going to switch local. So Fluvio profile switch, that takes care of. So now you can see local is selected, and I will say Fluvio cluster status. Okay. So there is nothing running. Hopefully, when I say start, okay, perfect. So this should work this way for you. So notice what it says. Like I showed you the streaming controller and the stream processing unit. By default, when you start a Fluvio cluster, it will start locally, right? Or you could say Fluvio cluster start -- local, does the same thing. It will start a cluster locally, and it launches one streaming controller, one stream processing unit. So it's kind of self-hosted single node, if you will, and you can pretty much do all the things that you need to here, right? And this is about 90% of your setup. The only other two things that you need to build the stream processing bits, I will show that to you in a second. But before I go here, I'll say Fluvio cluster start -h, and you will see that. I mean, this is a little bit intimidating, but the reason why I show you this is to show you that this system is actually, we've been building this for over 6 years. So it's like hardened to be cloud native, edge ready, can be deployed on a Raspberry Pi, is very, very nimble, but at the same time, it is secure. It is enterprise grade, production ready. It's not like a toy system, right? So you can see that it is on cloud. You can deploy using K8, which is Kubernetes. There are Helm charts that you can use to install and deploy. There is authentication, TLS, and stuff like that. You can define specific networking setup, certificates, all sorts of things, proxy addresses, right? So it's a very, very involved configuration, but you don't have to bother with any of those. You just start with local and you build it, and then in the context of this hackathon, we can help you come into cloud. Now, streaming systems, and this is basically the complexity of a streaming system, is managing a ton of infrastructure, and we make it very, very simple on InfinyOn Cloud. I think this is a good segue to only show you what InfinyOn Cloud looks like. You'd probably not have to interact with it for the most part of the hackathon, but I just want to show you what exists, right? So this is a cloud dashboard, and this is this Unreal. You can see that's the cluster here that I was looking at. There are 4 topics right now, right? And this is like a demo game, and the analytics events coming from there, and the table, which basically materializes this data. The monitor part shows when stuff is running, it shows a graph of data moving through, and you will see that in the video. The other helpers, I mean, then you can see org cluster secret. That's like enterprise level, again, security and this kind of stuff. But I suppose the most intriguing things for me, or the most like ease of use things for me, is like, even if you don't know streaming, this is a cool thing, right? So you can actually create webhook or WebSocket. You can create webhooks here. You can create WebSocket gateway tokens here, whereby you can find any data that you can pull from, and you just point it to the gateway or to the webhook, and the data will start streaming in, which kind of alleviates the need for building a custom integration, which is a connector thing that we will see. Custom integrations are still valuable, and most ETL companies show a ton of integration, but we make it easy for you using the gateway and the webhook to stream data in, and then you can apply processing. But that's as much I'll show you in InfinyOn Cloud. Maybe I'll show you how a workflow is deployed tomorrow or something. Let's kind of get towards the fun stuff. Let me just do a quick time check. So we are at 1:30. So it's been an hour, right? How is everyone feeling? Can I see some emojis here based on what we have shared so far? I just want to do a quick rain check here. All right. So far, so good. Seems like. Okay. This is exciting, because I mean, I don't want you all to get like really, oh, there's some couple of faces which were with tears. I don't want this to be super complicated. So far, we've not touched anything. I'm just showing you some glimpses of this thing, just to show maturity. So anyone who did not have a happy face or a thumbs up or whatever, do you want to come online? I see a few sad faces. Can I hear what is your question, doubt, confusion, concern? Can you come, Mansi? Mansi, maybe would you want to unmute yourself and let me know what is your cause for that emoji? Or sorry, can you please be a little bit louder? I'm sorry, I didn't catch that. Is that
trying and just seeing and remembering things are really tough.
Oh, okay. So you're saying that you're drinking from a fire hose. There's a lot of information. Don't worry, right? Like, that's why I wanted to have this session. I can give you, follow-ups and learning plan, which will be self-paced. And as we go through the examples, if you run 2 or 3 examples and follow along, you will get the code, right? These systems are a little bit intimidating when you start out. There are a couple of hands raised. Let me just hear from Tarun. You want to unmute and share your concern?
Hello, so can you
Yeah,
please go a little slow so that we can catch up to your session?
sure. I can slow down. Of course, absolutely.
If you don't
Uh,
mind, can you repeat the installation process?
oh yeah, sure, sure. Okay, yeah, sure, absolutely. And let me see. Who is the other person who has got your hand raised here? Can you unmute yourself? I can't see your full name here. Let me see.
Yeah, hello, sir.
Yeah,
Ganesh
yeah,
here.
go ahead.
So just wanted to ask that I'm using it on locally on my WSL. So would it be same as the Docker part or something different? Like, can I
Yeah, that
follow?
If you're using WSL, you can follow along. WSL will work fine. The only time WSL gives some kind of a, it might give you, you should not get it, but I have seen some people get some errors if the WSL configuration or the path settings are a little bit here and there. There are only two times where I have seen error in WSL. When you're trying to download, if you're able to download and start a cluster and stuff like that, you're
Yeah,
good to go. It will work.
I've downloaded it. I'm like running it on Ubuntu 22 point some version.
Perfect. Okay, so just in the interest of slowing down here, and maybe after the installation we can take a quick breather, and then uh, we will get into trying things out. So the installation, I will paste the, or actually maybe if I don't paste the link on chat because the chat might be disabled, if you go to fluvio.io, right? If you go to fluvio.io and click on Fluvio here, it by default goes to the quick start. Okay, and the installation is just this CURL here, this one. So I'll just run it again because that doesn't hurt. Yeah, and you just run it. It will download and install everything that you need. Once you have done that, what you would need to do is to copy that last line and paste it and enter. Right. Once you've done that, you have to say source, and in your case, if you might get bash rc rather than zshrc, right? But whatever it is, right? You have to say source and this thing right here, the last part that refreshes your batch profile, and then you can basically say fluvio -h to see that it's installed. If it's everything, it'll show you the Fluvio command line interface. Okay. Well, there are a couple more things that need to be installed. Perfect, Tarun. That's good. This is for the processing. For the Fluvio stuff, what we will do today, it's all good, but we'll just work ahead. So for the data processing, assuming that there's a Fluvio cluster running, for the data processing bit, we actually need to install what we call stateful data flow. I will share with you what stateful data flow is, but before we do that, let's just do the installation. And there are a couple of things here that it may be like gotchas. Now, this actually requires the Rust compiler to be
Excuse me,
installed there.
Debdyuti.
Yeah, go ahead. Lavanya.
Yeah, you can use the chat now. You're the co-host.
Gotcha. Thank you for letting me know. Okay, perfect. So just to explain to you why this step is relevant is because stateful data flow, this one, we close the cloud. This is the stream processing layer, right? Up until now, so Fluvio, what you installed is the stream transport, as we call it. It's the equivalent of Kafka or Pulsar. Stateful data flow is the equivalent of Beam or Flink or Spark. Maybe even Spark is micro batches, but it's for processing or the compute piece. And when you're doing compute, you're basically giving expressions for processing data to basically run compute on streams of data, right? And that's like code that needs to compile. and that's why you need to have Rust installed. So basically, I'll just paste this in the chat since I now have the ability to do that. That's excellent. Yeah, this is just from the official site. Just run that CURL and I will run it with you. Just copy and paste that. That basically installs the the latest version of Rust. And just when you get this prompt, you choose one standard installation. And then if you're running any of these shells, right, ZSH, Bash, or anything other than fish and new cell, most of us will be the first one, right? You just copy that line and run it. Now, just to check if you have Rust installed or not, you just have to say cargo version, or actually, yeah, cargo is the package manager, so it actually gives you that. Or you can type in rust up update, which here, rust up is the install manager. So let's say rust up update, and that will tell me that everything is up to date, basically. So that's what it is, right? This is just to compile code, so you don't have to touch it, you don't have to worry about it, but this is just like something that you would need in your system. And we don't package it within our installer, which we could, but it's a programming language compiler, right? So we don't do that. So this is just one thing. Once you have done that, what you need to do then is to go into this SDF quick start, and what we are using is Fluvio version manager here, FVM, and we're going to install this SDF beta 9. Now, the reason why, like I mentioned, this didn't get installed along with the original script is because this is in beta and we are launching very frequent updates on this, faster than we are adding updates to the Fluvio project. And this has gone through like 2 years of development. First it was in dev preview, then it was in beta 9, and we are closing in towards a version 1.0 release sooner than later. But you just have to say FVM install SDF beta 9. And you'll notice that some of those things will be redundant because it will add what you're getting extra is these couple of components right at the bottom, right? It's the stateful data flow piece, and then SDF web is a way where you can visualize your data flow graphs and stuff like that. Okay, so this should be good. This is the installation. You have got everything set up. Is there anyone who is still stuck in the installation phase, or anyone who is not able to do that? If you are, please let me know. Raise your hand or something, and we'll figure something out, right? If you're not, I see a bunch of thumbs up, which is good. So you're all set. It's running in your local system. And all you had to do to start the cluster was Fluvio cluster start. Hopefully you've done that with the local flag, and you should have a local cluster running, right? In my case, Fluvio cluster is already running. And we have no topics right now. So we'll start playing around with topics. Before we do that, let's, I know it's, you're all focusing for a while. So we will take a short breather. Before we do that, I'll just take 3 minutes because it's 1:42. I'll just take 3 minutes to talk to you about this. Is there a hand raised? Who's that? Let's see. Yeah, you can unmute yourself if you have a question.
Sure. I just am encountering one error while doing the Fluvio cluster status. It is saying me config error.
Config error? Did you do a Fluvio cluster start minus local?
I don't think I have done that. Where can I get that command?
I'll give that to you 1 second. Here in the Fluvio docs here.
Okay.
Here, do this way. I'll just paste it in the chat.
Okay, I have to start, right? Okay, I'm just on that page only.
Yeah, and you can add a local flag after the start. Give a space and minus local, like that way, and that should start.
I have not added local flag. Is it any problem?
No, it's fine. It should by default do local only.
Okay, sure. Yes, it's working now. Thank you.
Okay, good, perfect. Okay, so before we then break out, let me just give you a bird's eye view of what we have, right? So this is kind of the architecture. So what we did, and this is pretty dense, but I'm gonna just try and break it down, right? So see at the bottom, right? This is the system, right? So we were talking about Fluvio, we're talking about data streaming transport, distributed log, partitioning, events, and stuff like that, right? So this is this box here. So when you say Fluvio cluster start and you run a cluster, you have activated the bottom left box. You have a streaming transport engine that is running in your system. It is going to deal with events. Right now, you don't have replication. You're only one stream processing unit and you have only one topic, but obviously that system when deployed can be deployed with replication and stuff like that. And it is persisting that data because it's an immutable log. So every event that flows in, it will keep that state. It will keep that offset, and it will keep these events in order in the immutable log. Now on the right hand side, what you see, state management. This is what we installed in the SDF, right? Stateful data flow. Now, what that means is when the events come in, whatever order they come in the process of data flow, and I will recommend you in your free time, you can read this paper by Google called Data Flow. Okay, so it's I think it's been nearly maybe 10 years. I have to look at how long it has been, but close to 10 years maybe. So this entire notion of whenever you're processing data, there is time versus completeness, meaning all these events are arriving, you have to process them, and then there could be some late arriving data. And if you're processing it with state, you have a couple of things. You have the timestamp and the watermark of when the event actually took place, and you have the timestamp of the watermark of when the event was processed, right? And so you use that to deal with and make trade-offs between time versus completeness. And that is what is known as stateful stream processing. Now, state can be declared in the form of key values, and that's what you see as the document. So all the people who are familiar with MongoDB or Redis, you're familiar with a key value store, right? So there's a unique key and then a whole bunch of key values in a JSON structure, and that's basically pretty much every REST API, right? And that's also known as document store, right? So you can use keys to declare state, and then the temporal state on a timeline is based on watermarks. And you can store that in the form of objects and data frames. This is what is this box of state management. And this is the foundation of a stream processing system. So if you have the stream transport and stream processing, now you can build a whole bunch of things, right? And what those things are essentially operations, right? So many people call streaming systems or event streaming architecture an unbundled database, which means that you take the different parts of a database and you unbundle it and you deconstruct it, and you're using these specific parts, and therefore you have more control and flexibility. To a certain extent, that makes sense, right? So the operations that we apply using this stateful data flow pattern on this data are things like filtering, mapping, combination of filtering and mapping, flat maps. You can apply various pattern matching based on regular expressions. You can then create stateful processing, assign timestamps, assign keys, aggregate and apply like statistical computation. Now when you are saying, oh, you know what, I want the moving average over a sliding window, I want to compare the total and aggregate and stuff like that, we will see a few examples that will give you how these things work. And flush is basically a pattern which whenever you're closing a window, whether you're tumbling or sliding, this is also known as materialized view. You take the computed data and then you say that, okay, this is the computed data for this window, this is the actual record, you can call it, this is called materialized views, right? So that's the flush operator. Now you can write these operators, you can extend them by writing business logic or functions. So you can write it in Rust, you can write it in SQL. We have tested internally in Python and JavaScript as well, but there are some performance trade-offs when you bring in a system like Python and start interfacing with Rust. So this Python thing is not yet in production when you're writing custom logic, The SDKs are there, but when you're writing business logic, we will lean heavily towards right now SQL. And for all who write Rust, you can certainly write Rust. Now, all of these things basically form what we will call data flows, right? And then these packages, reusable components, these are all applying practices of DevOps, right? You do CI/CD, you do version control of packages, you share packages and reuse and things like that. So conceptually, right, this is an end-to-end system, right? An end-to-end system for event stream processing, which basically works from your data sources where there are events to apply various layers of transformation to produce applications, which are alerting applications, reporting, dashboard, and even inferences of operationalizing AI, ML, whatever have you, right? So that's the whole system. Now we are 150, which means that we have gone from the start time was 12:30, so like an hour and 20 minutes. So let us take 10 minutes and be back on the half-hour mark for all of you. I'll be back on top of the hour. I'll be here, and we will start back at 2. Does that sound good? Can I have some quick reactions if that is good for you? I think we are all set with the foundations now, so we can just get started cranking. The people who are Kalpit, actually anyone who has got a sorrowful face, I'm here. I don't have to go anywhere. Others can go on a break. If you have a question, Kalpit, you can unmute yourself. Let me know. I can support you with whatever you're stuck with. Okay, well, I'll mute myself. If anyone has a question, raise a hand, or else we will, again, resume in like 9 minutes or so. Yes, Priyan, I'm here. Go ahead. What's your question?
Sir, I want to get career guidance from you. Can I?
If you have a question, let me know.
Yeah, I mean मुझे career guidance चाहिए आपके पास से hackathon के regarding नहीं है मेरा question. कर सकता हूँ मैं आपसे पूछ सकता हूँ?
You can ask the question for sure.
या तो मैं सर प्रियन बाबरिया और मैं ब्लॉकचेन डेवलपर हूँ. सॉलिडिटी और सोलाना में दोनों में काम करता हूँ और हार्डेड फाउंडरी और एंकर जैसे फ्रेमवर्क में मैं अपनी कंपनी में काम करता हूँ. एंड ब्लॉकचेन सिक्योरिटी ऑडिटिंग में मेरे को आगे इंटरेस्ट है. तो फिर अभी और आगे बढ़ने के लिए क्या करना चाहिए? मैं अभी कॉलेज का फर्स्ट ईयर में हूँ और सीखने के लिए मेरे पास बहुत ज़्यादा टाइम है.
Okay. Blockchain security. I mean, right now, what I'm seeing is in blockchain, at least Web3, what I'm seeing is there are 3 areas, right? There's the on-chain stuff, there's a lot of off-chain stuff happening, and then there is a lot of interoperability related projects. In the infrastructure side, what I see is like there is a challenge around just making this data accessible. For example, if you look at Solana, to get the data, you have to work using gRPC. So you have to maintain the infrastructure of getting all of this data, and this is the problem that now not everyone will have the resources, right, to maintain and manage that. And also, like every block has 18,000 transactions, which will be of different currencies and different tokens. You may only be interested in a smaller subset of the market, but you still have to process all of this data every time. So I think there are a lot of inefficiencies in that, where the infrastructure people are trying to solve that. The security stuff, obviously, I think security is also tied to reliability in some sense, because I think Solana has had some issues, um, as an example. And I think obviously some other things, obviously in crypto, things like hacks and social engineering related stuff that happened recently, that poses some kind of threat. And on the other side, for all the off-chain stuff, right, and the interoperability stuff, there has to be integration and processing which is going across different protocols and things like that. So those are the main areas that I notice there is a lot of work going on. So you can pick any of those and kind of go deep, and that will expand the value of whatever you're currently working, I suppose.
Yeah, thank you, sir. I got it.
Perfect. Yes, Arnav, go ahead.
Good morning, sir.
Yeah, go ahead.
Sir, I've just started with the Rust installation process, as I'm a beginner. So after the installation, it's showing up to restart current set or set the environment variable. So what I should do?
Oh, the set the environment variable is like when you run the installer. So you run the first installer script, right?
Yes.
So the last line that gets printed out is basically to add the install location, the location of the binary to your path. So you need to copy that, which basically looks something like this. One second, I will paste it, but it will probably be different in your system. It looks kind of like echo $echo export path, something like that, depending on the shell that you're using. I'll just paste it in the chat here. It should look something like this, but it might not have .zshrc. Depending on the type of system you're using, it might say bashrc or something like that. You have to copy that line and paste it on the command line on your terminal and run it. And then once you have done that, what you want to do is you want to say source and something like that. But you would essentially have ZSHRC is the Z shell, is the flavor of shell or terminal that you find in Macs. If you're using Linux, you might have bashrc or something like that, right? So whatever that file is, you will just run that. Does that answer?
Okay, thank you, sir.
Yeah, cool.
Hello, sir.
Yeah, go ahead.
Yeah, so I just was exploring the docs, and I got a rough idea on what Fluvion is. So how do you think we should implement it in the hackathon? Like in where and where? What are the options? Like how, in which part should we implement that?
That's a very good question. So now that we have set up, what I'm going to do, like the next step is to look at the basic mechanics of like produce, consume, client connector, and then data flows. So I have an entire repository of a bunch of different examples of data flows, some with live data, some with synthetic data, and so on. That will give you a sense of how the end-to-end data flows kind of work out. I will say that currently most of our commercial users. They are in industrial automation, IoT, AI. Then on the other side, they are in like live analytics for gaming, trading, high frequency trading, crypto. And then there is like e-commerce, fraud detection, cybersecurity. So the platform is horizontal, so there are a range of use cases, right? And we have created therefore patterns that show you analytical application for live dashboards, alerting and monitoring type of application for telemetry and time sensitive sort of event driven apps. And then there are patterns to make language model calls and inferences from even traditional machine learning model APIs, like through Hugging Face and stuff like that. So these are like the three main patterns of applications. And now you can look at those patterns between today and tomorrow. I'll share with you a lot of examples and show you at least three. Then you can basically take that thread and apply your creativity to do whatever is, high resonance to you, like whatever you believe would be a meaningful, impactful project to your portfolio, right? All you have to do is to implement it in the pattern that you see in the documentation. So using Fluvio and stateful data flow to produce whatever type of application you have. Does that answer your question? I know it was a little verbose, but yeah.
Yes, sir.
Okay, perfect. And once the track is released, obviously there will be some more information around like the mechanics stuff, like how you do the submission and stuff like that. So I'm going to create a GitHub repository also. All right. Well, I think we just flew through those 10 minutes. I'm going to give a couple of extra minutes for people to return while I start sharing, and then kind of go from there. While people are returning, let me share my screen, and I will actually point you to a tutorial which you can implement. If you just follow that tutorial, you should be able to implement it. I'm not keeping it as a part of demonstrating how to do it. I actually showed you how you can get, how when you start the Fluvio repository, I get an alert notification, right? I will show you where that tutorial is so that you can implement it for your own. So you can basically implement that for your hackathon repository. So you see there is a create a data pipeline from GitHub to Discord. Now you might have to create, Discord, you can create a free server, right? Or any place where you can get a webhook. But if you look at it, you can do it without InfinyOn Cloud, right? So you can skip the InfinyOn Cloud piece. You can see you need the HTTP source connector, HTTP sync connector. I'll show you where those things are. Fluvio command line we already have downloaded. The configuration files of the stuff is there, right? The configuration for the connector and source and sync connector is there. And the smart module is, again, you can download those packages and all you have to do is to set it up, and then that's it, right? So it just, this tutorial actually shows you how to run the flow here. So I will paste this link to the chat if you want to implement it for your own repository, which you'll submit to the hackathon or something like that. Okay, now we will come back to our terminal and we're going to talk about, we have a cluster running, right? There are no topics. So let's just get this thing warmed up, right? And, get to doing certain things here. So as we know, everything in Fluvio is using topics. So it just helps to get a sense of how these things work manually before we start pumping data and using a connector, let's say. So I'll say Fluvio topic, and I'll say create because there's no topic, as I know. Fluvio topic create. And let's just say this is a test topic, right? And this is just to experience this sort of idea of topics and produce and consume. So once you create topic, you can say Fluvio topic list. Now, in the create thing, you could define the partitions, but since we are running single node, we will just keep it single partition and kind of go from there. And if you say Fluvio topic list, now you see, okay, this test topic is created. Now you can see there are some parameters here, right? So it's an immutable log, so you can set retention. Depending on the data, people can send longer retentions. Now, actually, how it works is this data will be stored as a log on disk, right? So in this case, local cluster, it will store the data on disk. When you're running it on cloud, it stores it in block storage. Primary, it will store it in fast block storage like SSDs. You could store it in a cheaper storage like S3, but that actually becomes slower. So obviously it kind of defeats the purpose. And so you'd prefer block storage. I saw someone's hand was raised. I'm not sure.
Yes.
Yeah. Go ahead.
Can so I'm just having one VPS. Can I host it on that?
Sorry?
I'm just having one virtual private server, SSH server. Can I host this on that?
Yes, you can. Well, what is that running on? Is that on AWS or what is?
It is from third party.
Okay. Yeah, you can. Yeah, I mean this barely takes any space at all, right? So
Okay.
this total download that you had is like less than 100 MB, all the binaries together. The core Fluvio binary is just like less than 40 MB. And I can probably show you, let me see, the activity monitor. This is a very lean system. Like it barely consumes anything. So you see Fluvio, and I
Yeah.
should not, this is the website. It actually, these two Fluvio runners, and
Good.
these two, it's like only like 40 MB RAM and barely any CPU. This, ignore this top one because that's browser.
That's I know. Chrome browser is
Yeah. Yeah.
Okay.
Yeah, so it barely takes any. I mean, idle time resource consumption is negligible.
And it would be fast, like as you said that if we host it on SC, it would be like little bit slower. But if I'm hosting it on my VPS server, then I hope it would be fast.
Oh yes, okay. So actually, because you asked that question, let me kind of do something. So there is a benchmark thing here, tool, and you can, wherever you run, you can benchmark it. So I'm just running it on my local, right? So Fluvio benchmark, I'll run a benchmark, and I'm giving it 200,000 records with a record size 5120 bytes, right? I'll just run the benchmark, and we'll see what is the latency and throughput. So you see, it's like less than 10 millisecond, P99, 345 megs a second throughput here, right?
Good.
And if you give it bigger servers, it'll do bigger, right? This is like orders of magnitude more
What's the
throughput.
specification
Sorry?
of your Mac?
Say again?
Specification of your Mac?
Oh yeah,
I think it
specifically.
depends on-
Yeah, of course. I have an M2 Mac. Hold on one second. I'll show you that one second. I have a beefy Mac for sure. I have a beefy Mac. One second. InfinyOn. Let me get that. There is a command that I had installed to show you that. Just give me one second. Where did I keep it? I can't remember where it is, but yeah, my system configuration. I think I've got this is an M2 Mac. I think this is M2 Mac, and I've got 64 megs of RAM. But again, like I said, the idle thing is like barely anything, right? So yeah. So yeah, I mean, you can run it on bare metal also, right? Like it's agnostic. You can run it on a Raspberry Pi if you have a tiny thing. I have a Raspberry Pi 5 running Fluvio as well, and you can run it on a bare metal also. Okay, so come back to produce consume then. So I created a topic, right? Fluvio topic list, and so what I'm going to do is I'm going to do a split of the terminal here. So I'll say Fluvio consume, and just gonna pass in test topic here. Test topic. And -b says from beginning, and this JQ is just going to apply some kind of formatting. This is useful for JSON data, so I'm going to skip that. So here I can say Fluvio produce, and then produce to test topic, and this basically gives you like a TTY to produce. Like, okay, here it just says produce, and it'll so say test, and you see it'll start right in here. Hello, we have to say hello world. That's customary, right? So this is kind of how it works, right? So you can see on the right, it's consuming the records. On the left, you're producing the records, right? Now, obviously, when you say you're producing the records, you would not typically do it manually like this way, but this is just to say you see the basic idea of a topic, and you can produce and you can consume, right? So once that is done, then what we can do is we can see how we got certain demo data endpoints. So I'm just going to Control C out of it, and I'm going to show you how we can get data from different sources. So let me just go to PWD. Okay, so this is actually one repository that I will link you to. This is a good time to share this link. This has all the data flow examples that are there, and we are going to go through some of these examples. We got a ton of data flows here. So you can see the gaming one that I was talking about is here. There is some basic examples that we'll go through, right? There's a bunch of different examples here. Someone has raised their hand again. Kanishk, yeah, what's your question?
So like, is it like something similar to stop and wait protocol or sliding window protocol? In stop and wait protocol also we have a streamer and a consumer, and then we send. Is it working similar to it?
It is very similar. Yes, you are right. So the way this works, and I will I'll link you this repository. We will walk through a few examples of this. The basic idea is that when you have Fluvio running, all you want to do is to run a few examples of this, and you will get a sense of it. But yes, you are absolutely right. It works in this idea of the log. The events are getting streamed. It's getting stored in the log. It's distributed. It's partitioned, and the producer is producing the data. On the transformation side, it's applying asynchronous transformations on that data, and the consumer side is now consuming the data from that offset. So it's basically the same, very similar pattern to what you described, right? So bookmark this repository, right? This is where all the examples are. And essentially, when you're building a data flow, even if you don't integrate to a new source or build a connector, this is how this is sort of the meat, the main. If you think of this as a burger, this is like the main like the patty inside, right, where all the meat is, or all the veggies are, whatever you like to eat. So let me actually show you something. Let me see. So this one is actually a live data set. So I will just show you this data coming in before we go into the data flow and stuff like that. So you will get a sense of what's going on. So there is this thing called DigiTransit. Okay, this is in Finland. So let me actually see what is the time in Helsinki right now. I think it's probably late. It's probably not a good time. Oh no, actually it's a good time. It's 8:30 in the morning. Yeah, we are past midnight. That's good. So DigiTransit basically gives you real-time API, and the sensors are on the buses and the trains and all public transportation in the city of Helsinki. And you can get this real-time vehicle position, right? And you can access it via HTTP, or you can access it using MQTT. Now, MQTT is the protocol of choice when you're using IoT mounted devices and stuff like that, if you're using robotics and things like that. So you can get this like vehicle positioning feed from this MQTT endpoint, right? So I'll just show you how this works when you want to connect to this data and get in some live data set. So I'm going to open the code here. So stateful data flow examples, CD data flows. I don't want to do traffic cameras. We'll do that later. Data flows and Helsinki transit. Okay. And I got to keep the consume here. So let me go to VS Code and open that as well here so we can see that code. So we are, again, remember, we are not talking about the stateful data flow yet. I'm only talking about the connector. So basically, the way we work things out is you can build any custom connector. A connector is basically the Fluvio client and authentication and serialization, deserialization. Where are you accessing the data? Do you have ability to access it? And then what format are you getting? And you can do anything starting from raw binary to any kind of serialization, deserialization. These things are packaged. So remember, we downloaded CDK. This IPKG file that you're seeing over here is downloaded in that directory and added to the git ignore. The only thing that we will look at here is that same data source that I showed you, Helsinki transit. It has this endpoint where now vehicle position is an endpoint, and then we filter it out by bus because, I mean, I don't want trains and other stuff as well. This way, at least it reduces some of the data because it's a ton of live data that flows in. And it's going to, you can see the MQTT source. Okay, so this is the URL, this is the topic. The output type we get is JSON. And then we apply this smart module transformation. So Jolt actually is well-known, a slightly esoteric sort of transformer. It was built by Bazaar Voice, I think, in the Java realm. So this is like a Rust implementation. And all it does is it applies a shift operation. So, you know, like in JSON, you get like nested, you got key values, and then inside of key values, you could have arrays and keys and values and stuff like that. In this operation, you can basically specify what keys you want the values for. Okay, that's basically this specification. And this transform, what it allows us to do, and you know, we can do JQ like jQuery, Jolt, and we've got a bunch of those things. I'll show you what we have right now. But in this context, what we are doing is we get this payload which has all of this, right? You can see feed format type, feed ID, agency, all of this, all this geo has this and that, and you know, we don't need all of it. Okay, so we just take the inputs that we need from here, which is like the latitude, the longitude, the vehicle ID, the route, which is the bus number, what is the speed, and this is the timestamp. Okay, that's what we get, and all we do is we are getting all of the payload. We are applying the Jolt transformation module on the connector, and we're saying, hey, just give me these 6 fields. Okay, so that's the configuration, and you can see that this is YAML. So all of the patterns of configuration that we use is infrastructure as code type patterns. So if you're used to Dockerfile or any kind of domain specific language, I mean, YAML is one way to express that, and we use it. So you know, this pattern works neatly to specify what where you're connecting, what are you expecting, and how this data would come. And you can obviously clone the whole repository and try it, but I'll show you this and link you the example where you can follow along how to do it, because the tutorial is again there in the documentation. All we have to do, and you know, all you will have to do, is to basically follow the README, right? It just says these are the steps. So CDK is connector dev kit. You have already got it installed, and it says go to hub. So let me show you the hub. Hub is basically a repository where you have like these packaged connectors. So I can say CDK hub list that shows if there is anything, what are the things that are available. And you can see there's like modifies HTTP source, HTTP sync, most of it is that. we got some, playful Redis, Graphite, this and that, DuckDB, webhooks, Kafka, MQTT. So we're going to use this MQTT one, right? So it's a CDK download, right? So it says, let me see, where am I? I should go to the connector. Yeah, CD connector, because I already have it downloaded. But in your case, if you're just following the README, right? Yeah, give me a second, Rohit. Let me run it, and then I'll come to your question. All you want to do is you want to download this. So it says CDK Hub download, and that will download. It will do nothing in my case, but the file is here. So it's just like a package binary, and the YAML is what I just showed you, right? So then you need to download the smart module package to the cluster. So Fluvio Hub SM list, I'll show you the smart modules that we have so that you know what are, I don't want to do that yet. Let me just, and SM short for smart module, let me just list that. So you can see there's a bunch of these that are there, right? So you can apply transformation, you can convert from CSV to JSON, you've got some probabilistic deduplication using Bloom filters, you can convert Parquet to JSON, regular expression-based patterns, RSS to JSON. We have like what you call Hacker News thing where we connect HTTP, get the Hacker News data, convert that into JSON right out of the bat. And actually, you get a bunch of XML data from different formats. Converting that to JSON is much easier to work in the RESTful API pattern. Then this is Solana specific, and you can see a bunch of these that are there. So these are mainly like at the connector side. You can say when you're getting data in or sending data out. And this, obviously, this Jolt one is what we need here, right? So I can say Fluvio Hub Smart. Actually, let me just copy it from the other side here. Why would I? Download that. So now there's one thing that is to note here. So when you're downloading the smart module, what it does is it directly downloads it to the cluster. Notice that it downloaded to the local cluster, whereas the connector downloads in your directory. And then what we need to do is the smart module is in the configuration, right? So basically, you say CDK deploy start. And this is all like copy paste stuff, right? Like if you're in that README, all you have to do is just copy paste and you will know what this is. So CDK deploy start, we are passing the package. So iPackage is the parameter, passing that package which we downloaded, and -C for the configuration file, which is pointing to the YAML file. So this actually is just a simple example of an integration using a packaged connector and a configuration file to connect to a live data source. And you'll see what will happen. So I can say CDK deploy list. So it has started this connector and it's running locally, right? So if I say Fluvio topic list, you see there's a Helsinki topic. And now I can do a Fluvio consume. And I'll say Helsinki -B and pipe that to JQ. Okay, so notice now this is actually live data, right? Like this is coming from the buses in Helsinki, and it's not getting the entire payload. It's just getting the 6 columns that I wanted to get. Okay, so let me go back and see who had their hand raised. By the way, so this printout thing, so there's one other thing to mention here. So all of this thing, when you're doing it self-hosted, is good. But when you're actually printing this, when you're doing consume, this actually in your live workload, when you're actually deploying it in cloud, this stream, this actually counts as egress. So when you're deploying this stuff on the cloud, the development methodology or pattern is to build everything self-hosted, and then you deploy it to the cloud, right? And in the context of your production deployment, you will only consume and print something out on the screen when you're trying to troubleshoot. We have all sorts of graphical interfaces to sort of monitor what goes on about. Like, I just started with showing you the connector, and as we build out a data flow with this kind of data, you will notice that we have observability and monitoring and other stuff built in as you're running the DAG. Now, there was a hand raised. I asked to wait. I wonder, do you still have your hand raised? Is there someone who has a question? If not, let me do a quick rain check. Does this make sense so far? Is everyone okay? See a few thumbs up. Excellent. That's good. All right. If anyone is confused or unclear or something, please, by all means, let me know. Again, this has been a while. I actually didn't share about my background, but I was introduced. So this is kind of a full circle moment in this regard. Like, I've not sat in a workshop like setting like this in a while, but I used to. This kind of takes me back. I think the last workshop I did was like data science with Python and stuff in 2018. Yeah, so it's been like 6 years or so. But since like 2011, 12, I've been doing all of this big data, Hadoop, Kafka, Spark training and stuff like that. I'd worked for a bunch of ed tech companies in India, so it's something I'm quite used to. I used to be in India and teaching people maybe in US and staying up awake in the night at the time in that way. But now, it's a different whatever. I saw someone's hand raised again. I'm not sure. I didn't notice your name. Please unmute and ask your question if you have one. Okay, if not, here's the shutdown script, because you don't want to fill up your entire disk space, because Helsinki sends a ton of data. So the last line is to shut down that connector here. CDK deploy shutdown, and that will shut down that connector. And I can say list, and there is no connector. So that stream is done. Cool. So the idea is this. You would get data from a data source, and you will start processing this data. So how about we do this? For the rest of today, I'm going to walk you through a very familiar data set or data flow, step by step. It's in the same directory. It's the data that we get from the New York taxi. I mean, it's very well known. If you see, you must have seen some YouTube video or tutorial if you've seen something in data. And I'll walk through that project, and I'll kind of show you what we can do step by step. And then you can start following along, and as much as you can keep up. In case if you kind of struggle, don't worry. You can follow. It's again, I gave you the repository. It's right here. Stateful data flow examples. I just showed you the Helsinki Transit connector. I didn't show you the data flow, but there is a data flow here. But I'll go to a more basic example of a data flow and kind of walk through step by step. Is what I'm looking to do. And in here, I'm going to use the New York Transit. So hopefully, is there anyone who is, can you give me a thumbs up if you're familiar with this data set, or if you've heard of this as a part of a project? Has anyone heard of this data set, the New York Taxi data set? It comes from this Taxi and Limousine Commission of New York City. Somebody? Nobody? Okay, fair enough. I got a few thumbs down, so no one knows this. That's fine. Well, you can find many open source data providers. It's just a matter of searching. Now, the interesting thing about this data set is that they provide all of this monthly. So they aggregate this data and provide this monthly in the form of a Parquet file. So this is classic batch, and they're giving you data from a data lake or a large scale storage in a particular format that is optimized for querying and stuff like that. Now, obviously, this is not really events, so we don't like that much. So we have a community repository. This is where you will obviously follow the protocol of namespace hackathon and where you have to synchronize and stuff like that. But for everyone who participates in the InfinyOn track, I'm going to create a repository over here. Now, the Fluvio community repository is where we like do a lot of wild experimentation, right? Like we have all sorts of connectors and things like that. Like we have an email connector. We can have like a video encoding connector people are talking about. This is like all sorts of wacky thing which will be interesting. We kind of try things out here. So in this utilities directory, which is interesting, what we did is we created this couple of utilities, Parquet chunk and Parquet to JSON. This Parquet chunk, what it does is it basically takes that Parquet file and it makes it into something that mimics events. Okay, so it's like, okay, if you get a whole bunch of old historical files, but you are not reading it as events, but you have to merge it with live data to essentially do comparison. And people sometimes they will do that, oh, you know what, you're connecting to this primitive legacy system in the context of industrial automation, and there is no way to integrate with this system via an API. And so what they will do is like, oh, you know what, we will give it to you as a large scale data dump. The legacy system, however, needs to be integrated with a live system which is modern and has APIs and stuff like that. So how do you take the events of this data and the data from this other source, which is kind of remote and proprietary, and merge them together to analyze, right? So this pattern applies in that context, whereby we can take data from bucket storage. Now, even if it's not events, we can apply utilities to chunk and stuff like that and load that really, really fast. Something to the tune of, I think we were loading, if you're familiar, if you've heard of this term SCADA systems, this is like hardware, IoT, this kind of space. They're called SCADA systems in industry. We were loading like 120 gig data dumps in about, I think 8-9 seconds or something, pretty fast, right? So what we do is we essentially chunk the data and then we load that in so that we can get this. And so we figured that, oh, we can apply this pattern onto, we can apply this pattern onto the New York taxi data set. Where did I lose it now? Jeez, sorry. Should go to stateful data flow. Sorry, I think the night is catching up on me here. What time is it? Stateful data flow examples. Yeah, it's 2:30. 1 more hour. I can do it. Yeah. So here, data flows, New York taxi, New York transit, right? This is the data dictionary, right? So you get license number, and that license number is of, you can see some familiar names here, Uber, Lyft, a couple more providers there. And then these are taxis. So let me just make it a little bit bigger here. There is dispatching base, originating base, date times, bunch of date times here, pickup, drop off, location ID, trip miles, time, passenger fare, tolls. This is a schema, right? So whenever you're working with a data set, so we basically use this utility here to chunk it up, and in the code, and this is Rust code, you don't bother with it, but in the code we have the function to chunk it up. Now, then we wrap it into a web server and make it as a synthetic data generator. Like, long way to say that, okay, we tinker around with bunch of stuff. This is the same data. We have made it into events, okay? And I just closed something that I shouldn't have closed today. Why do I? Seriously, I'm not sleepy even. Maybe I should take a drink. Sorry. All right, that's good. So here, what we are going to do with this data is this. We are going to we're going to walk through the stateful data flow. We split this into vendors, locations, and trips. The vendors data and the location data is static, right? Because there are only 4 vendors there. We know this, right? But the trips data, we made it into events, which is like coming in as trips. And we are going to we are going to build a dashboard like this, which visualizes the average tips, and we're going to do a bunch of querying, right? So we will see this. So there is a connector stuff that we will run with a package and a configuration. The static data, we will just pipe that into the topics, right? And we'll walk through the data flow. We'll have some SQL query stuff, and then we will go into building a visualization. So that's the rest of our time today, at least, and then we'll do open Q&A. And so what we want to do, let me just walk through these piece by piece, right? Come back here, go to that directory. I think the NY transit. Okay, cool. That's where we want to be. And I'm gonna close this one. Can I? Close and then open another one. That's good. Okay, so this is what we are working with over here. New York Transit. The first step here is to set up the connector, right? And if you look at it, I have a couple of connectors. The fast one is just sending a lot more records to show you how fast it can go, but I already showed you Helsinki, so it doesn't really matter. The slow one, you can see like this is looking at demodata.infinyOn.com. So this is the configuration of the HTTP connector. It's pretty straightforward, right? You could get polling or streaming. In this case, it's streaming, and the simple API version metadata. The name is Trips connector. It's using the HTTP source, writing the data into topics. A topic called trips, and this is going to be the live data, right? So it hits the endpoint, runs a get method, streams that data, define the delimiter, and that's it, right? Simple configuration. So you pass this configuration, launch a connector, and you'll start getting data in trips, right? So that's what we're going to do here. So again, like I said, if you follow the README stuff is developed in such a way that it will be like, follow it, it shouldn't ideally break, right? You should be able to get everything going. So you go to connector, download it. I should already have it. Let me see here. CD into connectors. Okay, that's right. So for you may not, because you'll clone the repository. What you want to do is run this CDK hub download to download the connector package. I'm going to close that for now. And once you have the package, as we did previously, CDK deploy start. And I think that's it. So find the I package. There's that. Trips connector.yaml. That's what we are passing in here. That's right. Okay. So that will start the trips connector, which will hit the demo data endpoint and start pulling in data. So now should be another topic here, Fluvio. Well, you can just do consume. And this is just to see the payload here, right? So this is what we are getting in trips. You see that this is the same schema of the location ID, ride flag, airport fee, base fare, right? And we want to calculate on the tips. So you can see tips is 0, tolls is 0, and then there's some value in tips here and stuff like that, right? Now, so the data is coming in. We can now start looking up the data flow, okay? So the way this thing works, and this is the unlock of the stream processing superpower, if you will. All of our data flows always would use this YAML configuration. This is the backbone of a data flow. Now, what I'm going to show you right now is going to have a lot of inline functions or inline code, right? Don't let that make you, again, you'll see a little bit of complexity. Don't let that deter you. This is just a simple way of building MVPs in our case. And by the way, a lot of this stuff actually um, can be code generated with copilots and stuff like that. So you can basically say, oh, you know what, this is my source data, and I want to generate the types. This is what my YAML file example looks like. We build the initial primitives, we pass in the docs, and we say, okay, can you generate it and stuff like that to simplify it. So I'm just going to collapse some of these things here just so that we can walk through them bit by bit. And I'm going to do a little bit of diagramming so that you know what's going on here. Let's see, topics, location, vendors, PU tips. Then we've got services. Okay, perfect. So let me kind of go back to this diagram that we saw, which gave us sort of this architecture SDF concepts. Okay, here you go. So remember how we said, okay, Fluvio is running. We have the state management with SDF. We want to run operators, right? So operators, transformation, and then custom logic, functions, SQL. These are the two things that we are now looking at: operators, functions, and this is an example of that, right? And so this is what you will find. So everything that you will see inside a data flow YAML file can be broken down into 3 main elements: types, topics, services. Now we already know what topics are, right? Types are basically defining a deterministic schema of what you're getting in an object, right? Now, when I say deterministic, it could be dynamic, right? There are examples of types where it's dynamic and you're saying, okay, I will just process raw binary, or I'll say, okay, I don't know what are the columns and I will infer it, and that's fine. But when you're working with APIs which have API specification, right? When you're working with data coming in from Solana, when you're working with data coming in from Stripe, Shopify, whatever it may be, there's obviously a specification, right? So if you already have the specification, that's your schema. And it obviously makes sense for you to adhere to that schema, because then you will be able to produce trustworthy results on your data, and you would be efficiently able to compute on your data. So you don't want to be like, oh, let's just go binary or whatever. If you're using Protobuf or Parquet or Avro or whatever it may be, those schema patterns exist for a reason. They exist for efficiencies. They exist for like good metadata management and deterministic schema and enforcing schema, right? So that's the types part. Then topics are quite simple. Basically, type objects represent the schema of the data in the topics. And then the services are what we have: the operators and the functions and the business logic. Okay, so that's basically the breakdown. So you start with a data flow YAML file, start with the API version, and there is some metadata of every data flow, right? And a data flow is like a DAG, right? You're running a workflow of operations. They could be individual services or daisy chain services, right? So these are like asynchronous services that are running, which could like go through a flow, and it could like run in parallel and things like that. And that's what we are building. Now in the metadata, it's simple. We've got like a namespace, a version, and the name. In the configuration, we have the serializer, deserializer. So you're working with JSON data here. And in the consumer, because what is happening is the source topics is the input data. In the services, you're actually consuming that data and applying transformations to it, creating intermediate topics, and then producing output data, right? So the consumer, you have to define, and this is for like fault tolerance type of scenarios, like what is your default starting point when a service starts? And then if the service fails or shuts down, it has to restart. It keeps track of the state or the position. It restarts on the last process record. This is what the position end implies here. So that's metadata and configuration. Now let's talk about the types, right? So we talked about 3 different breaking down that entire data dictionary, that schema, if you will, into the 2 static pieces, which has got the location and the vendors. And then the trips is the record that we saw right here. So this is trips, right? You see that this is trips. And then the vendor schema is simple, right? Like the vendor ID, the vendor name, something like that. And the location is location ID, location name, and stuff like that. So first, let's look at trips. Okay, so this is type trip. It's an object, and there's a property. We generate a key, and in this case, this is just like if you want to do deduplication, distributed hashing, you can generate a unique key, because we have an inbuilt key value store pattern to keep track of that. Then the key is string, and we make it optional here. Then all of the rest is a schema. So you've got the location ID, I32, PU location, access arrived flag, airport fee, and kind of goes on with that schema, right? So this is that object called trip, which is what we are getting by way of running that connector. So we define that and we say, okay, when the data comes in, this is good. And when we package this kind of becomes what is known as schema registry, right? This is what is running the data validation, right? You get a different data and there's an error, then you'll get an error. And I'll show you the observability part of it, and you will know where to troubleshoot and how to figure things out. Now, locations and vendors are basically lists, right? So they're types as lists, static lists, and they are lists containing the type location, and vendors, the list containing type vendor. So these are two types to aggregate a list of records. So location has, type is object. This location object has properties of location ID, borough, zone, and service zone. These four attributes. And then vendor has this properties of code and name. So, I think 01 is something, 04 is Lyft, 02 is Uber, or something like that, right? So we will see how that looks like. So this defines the type objects, right? And then we define this tip. This is the output that we want to produce, right? So you want to see, okay, what is the zone and what is the average tip? This is the output that we want to produce, and this is what we plot in a map, okay? So that's the output, and then this obviously is the list, which basically is a list of that previous object right there. So that's all the schema or types. Now we go into topics, and you notice the topics are just like referencing the type objects, right? So it says, okay, here's the topic called trips. The schema value is of this name trip. It's just referencing that type object, right? So that's what these topics are. So fairly straightforward. I think the main thing of every data flow is the starting point is basically defining the types. And we don't hand code it. There are some helpers. We open API spec. We run it through Copilot type scenarios to just get it, because sometimes these things could be really, really large, right? So we get like 80-90% there using these existing examples and Copilots, and then we just clean up whatever is remaining. So same stuff, location, trips, and vendors. We got these three, and then tips. Okay. So now how do we get this data, right? And this is where the processing bit comes in, and this is where the services part comes in, right? So there are three services, okay? And two of those three services are just about saving data in the form of a state object in memory so that it can be referenced and joined with the live data, right? So the save location and save vendors are identical services where we pass the data in. It could pull from a source. We will just like pass the data using a CURL, a curl. But all it does is it says, okay, every service will have a name and it will have a source. And then either it will save it as state or it will produce an output, which will be a sync topic, right? So in this case, save location has source. Topic is locations, which is the list, and basically just defines the state object where it will store the state. So its state object is called location table, and it's a key state, right? And then it just like defines a property, right? So he'll take the location ID string as the key, and then the rest of the thing is the value. So it basically stores it as a data frame, which is in memory. And I don't know if you can tell this or not, It's basically using a thing called Apache Arrow. It's like an in-memory data frame library. So that's what it uses under the hood to store that data in memory and fast access and so on. The rest is obviously the same thing: location, borrow, and zone, right? So the location ID is the key, and the rest is the value, right? Now it's getting this data and it's defined the input and the key. It runs a transformation. So this is where the operator stuff comes in. And here you see that this operator, this is a primitive you can call, that we will use to transform, is a flat map. And what it is doing is it's just like getting all of the records that we pass in there, applying a function to flatten the locations, and store that result as a vector. As a simple function to start doing that, then it uses that to partition the data and group it by key. So partition, assign key, run a function, set that location key, and then pass it to location, and then it stores a state. So basically what will happen when these three functions run in the service is we pass in a set of records of location to the topic. This service processes the topic and stores that data in the form of a in-memory data frame, which can be accessed on demand, right? And that's the service save locations. Save vendors is the same exact idea. It's just that it is doing that with the vendors topic, right? You can see that is the exact same pattern. Declares a state, keyed state, shows the properties, applies a flat map operator, partitions it by key, updates the state, voila, right? So that's two identical services. And then we are now building the trips table. So this one, it does a tumbling window operation. It's not a sliding window that we do here. We do a tumbling window operation, but you could obviously, same idea, right? We do sliding window for our billing, and I'll show you something where we run our own product analytics, our own billing and whatever through our own system. And, in some cases you need sliding windows, some cases you need tumbling windows, some cases you need hopping windows, etc. But in this case, what we are looking at is we are building trips table, start with the source of this live data now, which is trips, which is what we are getting. And we declare state here. In this case, we are now storing the state of the trips. And you would see that it will basically have the properties of that same schema, right? And you can basically package them as packages, the schema, and instead of writing all of these things down, you can call packages. Then when it applies a transformation operator, remember we talked about like a unique ID there. So here is a map operator, which applies a hashing function to generate a unique identifier for a key, right? Because you might have the same car going to different places and stuff like that. So you just generate a unique identifier and update the hash for everything. This is this function right here. And again, this inline function can be made into a package. I'll show you later. But this is just writing it inline as a prototyping mechanism. Now, once you have the hashing, you have the key. Then what we are doing is a 30-second tumbling window. Actually, let me make this like 10 seconds so that the window updates me faster. Actually, let's leave it 30. It's fine because I have to update the map as well. So for the tumbling window operation, whenever you're doing time-based, you have to have a timestamp, right? Whether it's in the payload or you declare it, it could either be the time of the actual event or it could be the time of processing. So we have assign timestamp, which runs a function to pluck the date time out of the payload and does a little bit of formatting using this dependency library. So this is how you kind of call dependencies or packages. If it was just a function, it would say, okay, just run this function called assign event timestamp without defining it if it was packaged. That's basically how it works. So runs this function, all it does, cleans up the timestamp, formats it so that we can compute on it. The partition is the same thing, using the key now, which we have. You just group it into these groups. And then in the update set, what it does is it updates. This is a materialized view, so it just updates that table. Okay, so you can see it's just updating that table, every aspect of that table. Now, here is the interesting thing. So this this key declaration and this update state, all of that is just like saying, hey, here's the schema, this is the record you're getting, run the validation logic, and put this in memory so that it can be queried. What you're going to visualize is where you have a query, right? So you can see this is where actually the materialization of that data is happening. So every 30 seconds, whatever is that table, okay, here's the value. This is what goes into your updated record set for this time window, and this is what goes on the map. And then we move to the next window and the next window and so on. This function is computing the tips, okay? And this is where you see that it's going to run a query, right? It's running a SQL query. It's fairly simple. It's choosing the location, zone, and average tips from this table. It's grouping by location ID, and that's the output. And then you just describe what the rows look like, and that output will be produced to this sync topic called PU tips, right? And that's it. So basically you run the 3 services, which will give you the analytics to basically, I don't want to save it, to basically run this data flow. So all you got to do now with your SDF and stuff like that, we have walked through it, is to say, I gotta go back one level. You be in the directory where the data flow YAML file is, and we say SDF run. So basically what this does is it spins up a worker to do this streaming computation, right? Now, as it builds, so what you want to notice here is that in this ny transit directory, these are the files here. And as soon as I run this, and I'll pass the UI flag as well, and you'll see why, because it lets me visualize the DAG. But now it's starting to build the data flow. So you see loading data flow, building packages, right? So this is like someone said Ruby on Rails, right? So notice this directory came about, .sdf, right? So it basically deterministically generates the code and like processes all of this YAML file and the structure of that data flow to create the entire scaffolding that is necessary to build, compile, and run this project with all of the dependencies. So that's what it is doing. And since those functions that is there in the example, the logic of the function is Rust and SQL, you see that it is actually building it. There's a runtime, there's a Rust project, and essentially the functions that we defined, that's right here. And notice this WIT, right? So basically what happens is the code that is in these functions, and this is really the magic of this platform essentially, right? This is the bleeding edge innovation, if you will, because every other streaming system execute using Java virtual machine or something along those lines, right? But in the case of InfinyOn, what happens, all of these functions and these types, objects, etc., they all compile to WebAssembly. That's what you see in the WIT. So inside it, all of this that it builds, right? Save location, save vendors, build trip table, all of these different functions. You can see that all of this .wit, they all compile to language agnostic, type safe, absolutely safe WASM component model, right? So WASM interface types, which can then run on our platform, which is why now, instead of these functions being in Rust, I have developer environments where I can write this in JavaScript or I can write this in Python. It's just that to make it production ready and give the same amount of performance, that's where we are doing a lot of work to make it as good as the Rust stuff, but the SQL stuff is good, right? So now it has sort of built that project, and remember I passed that UI flag, so I created all these topics and things like that. I will click on this, and this now opens the DAG, right? This is the DAG. This is what we have built, right? So you got location, services, and these are the functions that are running. We can actually browse the data. So right now you can see the location table doesn't have any data because we just launched the service. We can produce data to it. So let's do that. come here and go to the README. We're running the data flow already, so let's just do this, right? So I've got this demo data in the endpoint again. I'm just like producing that as a one-off. So I'm looking at locations here, location table. It's empty, and I'm gonna open this on the side. We have a locations topic, so just gonna produce that. So Fluvio produce location, and we pass in the demo data from here. And as soon as I do that, you can see that it ran this save location service, and you have data in the location table. Okay. Obviously, the trip table, or trips table rather, is getting data, right? And there is no dependency, right? These are individual services. We will see change service. We have 3 more hours tomorrow to go through more stuff, more exciting stuff. So anyways, like, let me just put the data in the vendors table here. So I should say CURL. There's the vendors one. And we've got the vendors data here, right? So now what we can start doing, we've got the trips data, we got the vendors data, we got the location data, and we can inspect more of this, right? When we have a change service, we can see what is sending data from where and so on. And when we look at this interface on InfinyOn Cloud, it actually allows you to edit these functions in that context. But in the self-hosted version, when we are looking at it, that edit functionality is not there. But anyway, so this service is running. Now what we can do is we can, let's say, Fluvio consume it. So we got all these different topics that are there. And we can look at the PU tips topic, which is the computed topic right here, right? And this is basically going to update every consume, I should say PU tips. And this one will update every 30 seconds. Now, while this is updating on the side here, as we are looking at SDF, pay attention to this place here. So I mentioned observability and monitoring and all of that, right? So I can say show. Actually, I can say help here. And I will say, okay, I can do a few things. I can run SQL queries here. I can show stuff. Okay, so I can say show, maybe -h. So I can say show state, and I can see the help. So I can say show, and in the cloud, I can say show data flows as well. Show state. Okay, so now notice this, right? This is basically all of your observability, monitoring, and stuff like that, right? So you see, let me see the trips one, right? So when you see this update trips table metrics, right? Build trips table. So every function that you're running that is part of a service like an operator, right? You have state that is storing. So like 199 records succeeded, 0 failed, right? And you can obviously easily access it via API and troubleshoot and figure out what's going on, right? These save locations, 265 records, and the 4 vendors, these are the states that we stored as tables, right? Which we saw there. So state, and you can see this is exactly the same thing that we see over here, right? And then all of the metrics are essentially how many records have processed, how many failed, and ideally you don't encounter failures. If you do, it will give you error, and you will see that in the metrics. And then we have this one, the trips table, right? So if you say show state, that will change because that is live data, right? So I say show state again. Now it's 63, right? So the window closed, and this is just like changing, right? The trips table state. You can see that number is updating. 159, 166, 175, 184, 191, right? So it will go 30 seconds, and at some point it will close that window. So it updated. Now it's gone back to 10. So you see on the right, that stuff updated. Now, obviously, this is kind of hard to see because, okay, this is like a command line interface and what have you. This is where we can take it up a notch, right? And we can visualize the data. So what we can go and do is in this repository, you notice this process data, there is a directory called visualization. And there's a virtual environment, and this visualization is simple. I'm just going to copy this. So just walk through what is going on here. We will use the Python code here to visualize the data. So I'll walk through that plot.py. But basically what it does is uses WebSocket, right, to listen to the topic. So you just set the window interval, function swap, this and that to basically keep the data updated. But it will just get the data directly from the topic and visualize it. So you can come to this plot. We use Folium, the well-known Python thing, and GeoPandas to get a map distribution, map-based visualization. And then here we are using the Fluvio client to consume, right? So there's Fluvio, there's offset, and you're getting just JSON records. And remember, this is the average tip data that we visualize, right? So we specify the NYC map. We specify the data that we are expecting here, initialize the tips count. And then we add the element, set the refresh interval, and we do some basic offset logic here, right? And we start getting data, right? So for the zones, we color code the fill for the zone. And here you can see the consumer. So it just consumes the data in the topic, and it's going to look through that zone and average tip, which was in the output data from that service, right? So simple to run this visualization. So I can go to CD visualization, and then you can say source, activate the virtual environment, and that's again in the README. And then just run the plot.py. And once we got that, all I have to do is to copy this index.html and come here and plug that in. Jeez, did I not copy it or what? Okay, I'll copy it again. Copy path. Okay. And then I gotta paste it here. There you go. So here is now a map, which you can see is updating the data of the tips based on the table. So you can see the countdown over here on the top. As the countdown goes and hits 0, it updates every 30 seconds. So you'll notice that this now changed, right? So that's like a live dashboard, right? So this is coming from the data that is being processed by this right here. The output that it is putting out is this PU tips, right? Which is mapping out here. And this entire data flow processing, if you will, to visualize this data that is live updating. All of this practically is built using a single, what we call unified composable platform, where you integrate data from your sources, produce data, whatever your source may be. If you don't want to build a connector, send the data to webhook gateway or WebSocket gateway. Once it's inside of a Fluvio cluster in topics, you have that data stored. You will have that data for as long as the data would be retained. And then you apply various levels of transformation. You saw a couple. I'll show you a few more tomorrow to round out a fully formed experience, right? Process it. Then it produces output data, which you can consume in an application. This is a type of application where you're visualizing in a dashboard, which is live refreshing, live updating a window-based aggregate and materialized views. You can obviously send data to databases for historical storage, S3 buckets, and what have you. You can also consume that as alerts, as you saw in the GitHub thing, the people on our thing who are starring our repository and that kind of stuff, right? So you can have telemetry, you can have alerting, you can have these DAGs and services running, and all of this effectively is running on a single platform, right? So that's kind of what the idea is. So I think what's the time, right? It's 3. So we've got like 20 minutes or so. I think what I want to do is now address any questions that you have. Before I go to that, I'm just going to show you one other thing that I mentioned but didn't show you. So I told you about packages, right? So you see UE Analytics core package and UE 2D Analytics package. These packages actually have like functions inside of them, which can then be used inside of data flows. So like an example, just to show you. So you import a package, you have types, you have package, you have function, and you call it, and then the function kind of gets neatly put into a version control packages and stuff like that. So I'll send you this video. I know there is a lot that we have covered, and we have a couple more data flows to go through, but I'm going to pause content tutorial now. You should be able to run all of it, but let me see you, and let me see what questions you have. Let's spend some time answering any questions that you may have, if that sounds good. Well, let me can I get reactions here? It's what time is it for me? It's 3:10 a.m. for me. So show me, like, hopefully you're attentive. I don't see any of you, but like did you get all of this stuff, right? There's a lot of stuff here. Yeah, and I'll show you like some of the swag. This is like it, like this is one. I'll design some, but this one says JVM is working hard. Please be patient if you want, right? If you want to use old stuff, or you can get a better engine, which is the one that I showed you. Anyway, so I saw a hand raised. Who raised your hand? Please unmute and ask me a question.
So in tomorrow's session, can you like create a data flow from scratch and show us, like instead of running an example, can you show us how to do it from scratch, like so we can implement it?
Yeah, that's a very good point. So tomorrow's plan is this. Let me kind of share what I have planned for tomorrow. What you saw, right, the creation process of that would be like step by step what I walked through, but instead of like reading code, it would be like, hey, how do I write the type object or schema? How do I write the function? So yes, that's one thing. I want to go through one connector example, how you can build a custom connector in case if you needed to. We will use one example of someone that built in a prior hackathon a Google Sheets connector, so just like we can get an understanding of sending data on the other side. And I want to go through an example of making large language model calls, because the hackathon after all is AI and Web3. The Solana data stuff, from people that work with us, I can share some Solana or Ethereum stuff if you're working on that. But I do want to share, there is an example, I don't know if you saw it or not, there is an example running Hugging Face on camera images object detection, and there is an example of I have to complete the Blue Sky example of sentiment analysis on Blue Sky, and there's an example of just making large language model calls to OpenAI or Cloud or whatever, right? So I will pick one of those examples and show it first, and then I will show one example of like building out from scratch. Let's say you take an OpenAPI specification. I can even probably make some ChatGPT or I don't know, Cloud calls to say, okay, here's the OpenAPI spec. Can you give me the types in my this thing? Because that's kind of my workflow when I build it. I don't go from scratch like, hey, here are the 500 columns. Let me define everything by hand. And one connector. So those are the 3 things that I want to get done tomorrow. So long way to say yes, I plan to do that. Any other questions? Is there any conceptual question, anything that you want to ask about event streaming, event driven architecture, live analytics? There are all sorts of like contentious things. I don't know what you're exposed to in the context of early career engineering college stuff, but for people who are experienced, I mean, I've been working for nearly 20 years now, but people who are experienced, there is a lot of I don't know, weird semantic debates and contentions. If you don't know about it, I don't want to expose you to it. But if you have any questions about or doubts about how to distinguish or differentiate, and if you've heard something like, oh, real time doesn't matter, no one needs real time, everyone says, or something like that, I mean, I'm happy to answer any doubts or questions that you have around this space. I'm not hearing any. If there are no questions, then we can actually, I have a Slido for the end of the session. So maybe I can share that. And yeah, Mansi, go ahead.
हेलो सर, सॉरी सर, ये मेरी सिस्टर की आईडी है तो
That's
मेरा
fine. Go ahead.
माय क्वेश्चन इज currently I am pursuing BTech second year.
Hmm.
My interest field cloud computing. Can you suggest me a roadmap?
I see. Okay, good. Okay, so let's do this thing. Okay, what I'm gonna do is I'm gonna give you another link, and if you have any questions, why don't you type? So I got the cloud computing one. Let me just share this link with you. Copy, and I'll present this. There is another hand raised, Nitin. Yes, you could unmute yourself and ask the question while I send this to the chat. You all can join this this Slido. This is a different one. I'm going to start the first interaction. So we took a initial interaction of how well do you understand the concept of event streaming, stream processing. You said something before the session. Right now, I just want to take a quick pulse of what is it now after the session, after the first one. What to and yeah, if you have any question, please ask. Please ask, Nitin. Go ahead, unmute and ask the question.
Sir, currently I am in first year of BTech NIT Jamshedpur. Sir, now I have completed like most of the around 50% of DSA in lead code. But sir, 1 minute please.
Hello. I had a question. What would you be looking when evaluating a project for the Fluvio track on the hackathon?
Okay, good question. Okay, so let me take the cloud compute one first. So you said you're interested in cloud computing. What's your career roadmap? So the thing is that cloud computing is, if you look at any hyperscaler, right, it's super broad, right? You could go branch out into specific domains. You could do things like just managing applications and databases, which is more like DevOps. You could do things like site reliability and ensure that there's security and stuff like that, which is more like platform. Or you could do things in the application layer where you're building various applications and data flows and things like that. So you could do, when you say cloud computing, you could do in different levels of abstraction. So I would recommend, if I were to give generic advice without knowing your background, I would recommend that you find out in your coursework what is it that you like to do. Do you like to build applications, or do you like to maintain infrastructure and orchestration and sysadmin type work, or do you like low level things like compiler and kernels and firmware and these kind of things? So depending on the level of abstraction that you find yourself most comfortable, you should pick a path, right? Now, if you find, and there is this something, a pattern that I will tell you. If you are finding yourself to be very comfortable with a higher level pattern where you can build applications, use APIs, or build, let's say, data science, train predictive models, analytics, and stuff like that, it is going to be harder comparatively for you to go down into the level of compiler and kernel and stuff like that. However, if you are already good with compiler kernel infrastructure and you want to go to the higher level of abstraction, you need to understand, app flows and workflows and data. In my experience, I've seen that to be marginally a little bit easier, but you cannot, it's never in your control the starting point, right? Like, what is it that you understand easier compared to other topics? There is a starting baseline, and then you find out what are the areas that you work on, and then kind of go from there, right? So I would say, like, just take a look at that. There are too many options. Just think about it a little bit and try out a couple of things and time box that, and then you'll find out. Now, Nitin's question is incomplete, so once Nitin is back,
Sir,
I'll get that.
sir,
Yeah,
I have come. Sir, actually, I was asking that I have completed like DSA to a major extent, but now actually I have interest in ML and AI. So I am
sure.
not getting how to pursue that.
Well, okay. So ML and AI, again, this is again similar to the crowd computing question, right? So when you're talking about ML and AI, you have to think about the entire workflow. So let me just quickly um, do this. We were working on this stuff, right? So ML AI, if you think about what happens to the data, if you think about data lineage, right? You have, let's call it source data. I don't want to use things like raw or whatever, right? So you have source data. There is a ton of, let's say, transformation. There is analysis. There is profiling. And this kind of goes from, this kind of goes from business analytics, business intelligence, to predictive analytics, to data science. Okay. Now, from there, you go into machine learning modeling. So then you go to like training models. Okay. Then you go to optimizing models, training models. Let's see, optimization, optimize / evaluate, etc. And then you go to serve, right? So inference and scaling. So if you look at the entire sort of pipeline, I'm going left to right, right? The most complicated things are actually, let me just see different colors, right? Most complicated, hard to do things are the operational ones. Okay. There is a degree of complexity in the training models and optimizing models and what have you, but like today, if you were to look at it, analysis and profiling, like there are lots of libraries. It's pretty easy to do. You can visualize data, load it in a data frame, figure out, make some inferences, stuff like that, make some sort of analytical or statistical judgments on that data. But the hardest thing is to transform the data in a way that it is useful for creating this flywheel of training, optimizing, evaluating, and operationalizing models. Okay. So then if you break it down and decompose this, you have to say, okay, fine. Are you wanting to specialize in the realm of algorithms and building new models? That part is mostly commodity, because like you see, there are a lot of different models, and most of the new stuff that come out are incremental. But if your knack is in that direction, you want to learn that, right? So then essentially you will have to get a baseline of all of the different algorithms that are there, today in use to make machine learning prediction, deep learning predictions, what have you. You have to then obviously understand how those models are tuned and optimized and trained, and some of it is in the data, in the transformation, pre-processing, post-processing, and the other part of it is essentially hyperparameter tuning and weights and biases and this kind of thing. And then operationalizing all of this inference scaling, this stuff is actually the hardest thing, because then again you have to think about edge and cloud and where you run the model, what is the privacy of it, and how much does it cost and all of that stuff. This is kind of again ML ops or DevOps kind of stuff, right? So you cannot obviously learn all of these things, right? Directionally you have to say, okay, what are the things that you currently already know today, right? What are the muscles that are in your body that are already strong, and then you're trying to use that as a foundation to like go into other directions, right? If you want to, this training model and optimization evaluation kind of link to each other, but inference scaling is a whole different beast. Transformation on the other side, you can think of pre-processing, post-processing, drift monitoring, measurement, and stuff like that. So these are the areas where I would say there is like value in picking a thing and going deep and getting it, and then learning something adjacent. If you want like structured learning, I generally think that any of these hyperscaler, whether it's AWS, GCP, or Azure, or IBM, or NVIDIA, or whatever, like all these big companies, their courses are all good, but pick one. If you try to like go and learn every different ones, they have different quirks and oddities which will confuse you. So pick one and go. If you're looking at, I would say, training models, optimized evaluation, I would prefer for people to look at NVIDIA stuff more than others. If you're looking at inference scaling and so on, I'd recommend AWS. If you're looking at transformation and stuff, that is a little bit more generic. Hopefully that gives you enough of a starting point. Now, I don't remember who asked the question about the evaluation. So here is the idea. My goal is to give you all of the examples, right? So you will get the points for using the system and the patterns that we show you. There is no what would you say? There is no deduction of points or extra bonus or whatever if you write Rust or SQL over the none of that, right? The entire idea is like of evaluation is in two ways. One, assuming that you are using the system, how useful or impactful, and this is kind of fuzzy word, right? But we will see, right? So when you make a presentation of like, hey, here's the identified problem and here is how we solve this problem using like a continuous data flow pattern and stuff like that, how meaningful is it? And it could be in two ways. One is you're a student or you're working in a context, so there could be something that is meaningful to you, which will come through if you are explaining the problem solution scenario. Or it is something that is meaningful in a grand scheme of things in a domain. So for example, fraud detection, finance is useful. High frequency trading, some kind of algorithmic trading, this thing would be useful. So it could either be relevant in a market or in your context, but it will essentially be figured out by your problem solution pairing, right? So that's the abstract part of it, quantified in some sense. So we will apply a grading in that based on how you articulate it and how your solution solves the problem. That would be that. The other part of it would be essentially how you use the different aspects of the system and the patterns that you see to implement an effective solution and essentially present it in a neat manner. Meaning, the things that I'm showing you, these patterns, there is like a thinking behind building data flows, right? Like I would say one thing, right? I'm pretty sure you're familiar with this entire construct of vibe coding, right? People going to Cursor and stuff like that, and you're generating a lot of AI generated code, and it's fine. We use that. I mean, even developers and experienced people also use that. But there is kind of a pattern which I don't know many people notice or not. If you use, for example, Lovable or Replit or whatever, any of these agented, Versal V0 or whatever, right? A lot of these products are actually helping you to build a bunch of monolithic solutions again. And what that means is you're like building a 3-tiered application which will scale up to a certain limit, and then you will struggle, right? And this is a mindset or a mental model or a pattern that we are trying to break, right? So that's why how you think about the data efficiently, technologically, would be in terms of um, not processing records that you don't need to, not deduplicating just because you have to. Because in traditional batch processing or in traditional analytics, what happens, like, here's my master data, here's my database, this is where I start with. I need a report, create another table. I need this other analytics, create another table. I need this other thing, create another table. So you're basically doing processing, creating more data, creating more, like, taking more storage, more compute, unnecessary transformation, unnecessary this thing. And that's not efficient design, which is why most, like, data projects either are failing or they are, like, way too expensive and the customers are not paying and the business is, like, failing economically or functionally, right? So that's the second aspect, where it's like how you're designing your data flow to solve the problem. Here's the source data, here's some kind of potency of what that data is actually capable to produce. How are you effectively processing it with minimum waste, right? In the most effective manner. And we're giving you all the building blocks, right? So you can think of this as like a jigsaw puzzle or whatever, right? Or Lego bricks, whatever, and you're building with it, right? So to summarize, because I kind of gave you a long-winded response in the second part, right? Two aspects of it. One aspect is how efficient were you in crafting your data flow in terms of, like, hey, here is your schema, this is how you process it, and the flow of your services or operations on it. And the other side that I mentioned earlier was, like, how relevant or meaningful is that problem and the solution that solves that problem. So those are the two main criteria, and the rest is, like, just follow the pattern that will be given in the problem statement in terms of submission, what do you call, like, the grammar of it, right? You're submitting a paper, it should be, like, following the protocol that is there. um, uh, that's kind of assumed, but I just call it out, and that's basically the entire evaluation criteria. Hopefully that gives you a clear enough response. Does that clarify, or do you have any follow-up? Okay, sounds like you got it. Okay, I got a thumbs up. Good. Okay, is there any other questions?
Yeah, just to follow up on Deep's answer, guys, we would be having a proper, a technical paper on each of the problem statements, which will list out how each of the problem statements or the tracks would be evaluated by the respective judges for each track. So you don't need to worry about it.
Perfect. Kanishk, do you have a question?
Yeah, yes, sir. So just like this was completely new to me. So for tomorrow's session, if are there any prerequisites which we should learn by today or something that will be helpful for
No,
tomorrow?
there's no prerequisites, right? So the thing that you can do, and this is, like, recommended to everyone, right? Like, this is a new, well, at least in some sense, even though conceptually these things have existed, not a lot of people are already aware of it, right? So I would recommend, if you have followed through just setting up your local environment, just tinker around with the link for the stateful data flow examples that I shared with you. Just play around with it, right? Like, just read the readme. It's step by step. Most of it is, like, less than 10 steps in all of this, right? And all the stuff is, like, self-contained. Most of it you should be able to run without any hassle, other than if you're like using the open AI one, you might need an API key or something. But most, like 80% of the data flows in there, you can run it because it's based on synthetic data sets or data sets that we are hosting in our servers. So you can try the demo, just get a feel for it, right? And whatever we are going to do, I'm going to I'm going to see if I can send out whatever we are going to work on earlier than tomorrow night. But I cannot promise that, given that I'm already kind of sleep deprived and my schedule is going to be a little bit upside down for the weekend. But this is the comfort I will give you, Kanishk. While you work on the hackathon, we are a team of 10, right? I told you we have a thing on our Discord. If you're working on our track and you're using this and you have question even while doing it during the week 10 days, we will help you out. Until then, it's just same basic exercise like push up, squat, crunches, burpee, like that way only. Just look at the repository, try out those things, follow the workflows. If you encounter an error, come to our Discord, tell us what it is. And it will not take a lot of effort, honestly. Like if you spend a couple of hours for like 3 to 5 days, you will start getting the hang of it for sure. Like it's just like getting used to this new playground, if you will.
Yes, sir. Thank you. Can you just share the Discord link once?
Yeah, sure. I will share with you I did not share that explicitly. So InfinyOn hack hazards. Let me just find the copy link here. Okay. Yeah, there's an invite here. Okay. Yeah. So I just created a specific link for that full forum channel, right? I think if you click on it, you should be able to get to something called InfinyOn hack hazards, right? And our team will be monitoring that, and that channel would like find. I mean, there are other channels as well, but this is the one that we will monitor for the period of the hackathon to make sure that everything is sort of in one place, if that makes sense.
Are there any more questions, guys? I guess not. So, first of all, it was a very great session, Dave. So, all of you guys, can we please have a round of applause for Dave for staying up late? It's over 3 o'clock there.
Yeah, it's 3:30. No, it's all. I mean, like this is what I'm saying. So there was back in 13, 14. I would have like some sessions where I was still in India, and I will like do sessions when it's morning in US, teaching people all this Hadoop and Spark and so on. So it's like the other way around. But I hope this is the main thing, right? I hope that you all learned something today. The poll still was not encouraging enough for me. It was like still 2.8 or whatever. But hopefully you try some of these things and find some value for it. But great. I look forward to seeing you tomorrow. And have a great rest of your day. And thanks for hosting it, Pradeep, and others.
Thank you so much.
So we will get the recorded version, right? Like recorded video.
Not yet,
this
not
session.
yet, because we want first the bootcamp to get over, because otherwise there is no point for you guys attending it, right? If you are attending and someone is not attending.
Because due to my network issue, I missed some.
We will look into it. We will look into it. But attend tomorrow's one first, then we can see.
Okay.
And all of you can, also share your reviews on our Discord channel, on the Fluvio Discord channel, the link which they've just shared. You can also post about the event on your socials, and feel free to tag us, tag Fluvio, tag InfinyOn, and we would be seeing you tomorrow as well. We would send you updates over Luma as well. And we are open to any questions you might have, or we can just wrap up.
Perfect. Well, thanks for hanging in there. I mean, obviously some people have gone by, but hopefully this is useful, and I will share the code, and that's what matters. Like once you're hacking, just get into the code, get into it, fix the issues, and come with a winning product. That's all. I look forward to seeing you tomorrow. I'll get a little bit of a nap now. I'll talk to you soon then.
Thank you so much, Dave.
Right on. Cheers. Bye.
Thanks.